Good evening. This is Matz, as you know. And my biggest contribution to the world is naming the language Ruby. So if I name it Coral, we don't have this conference. Anyway, in 1993, in Japan, the bubble economy was crashed. It's the beginning of the deep depression. We're still suffering. And in that time, I was working as a programmer for the software making company back in Japan, and my project was canceled at then. So I was not assigned a job. So I was in a maintenance mode. So sometimes my clients called me, so your program don't work. So I just answered, okay, reboot the machine. So I had time. I had a computer on my desktop. So I had time. I had no assigned job. Unfortunately, I was not fired. So I started my pet project. It was to graduate in Ruby. So Ruby was born as a toy, and it's the afterbirth of the bubble economy. And it was due to the canceled project at the spare time. Then the little bit background is I have been a programming language geek for last, I don't know, 30-something years, since my high school age. So I wanted to learn about the programming language. I wanted to create my own programming language for no reason, just for fun. So the many programming language designers started developing his own programming language, mostly for some reasons, like to do some research project or to do some kind of business project. Like James Gosling wanted to create a programming language for their embedding systems, the set-top box. So he and his team created the programming language named Oak, but some irritating trademark issues forced them to rename the programming language into Java, then some larger systems pushed programming language to the enterprise, and they somehow succeeded. That's how we have Java. But Ruby, there's no reason. I just wanted to create one. In creation of programming language, I wanted to use my own programming language, as I really love to dog fooding. So, reflecting my programming life, I use language like Shell and Pro a lot, just because to process some kind of text data. Back then, we don't have any web. Yeah, we had the web probably in some place in Switzerland, but we didn't use the web that much back in 1993. But the Pro was there. It was a great tool. It named after the practical extraction and remote language. But most of the Ruby programmer, call them the pathologically athletic rubbish lister. Yeah. And as a programming language, it's pretty useful, but ugly. I really respect the guy who invented the Pro, the Rally Wall. But as a language designer, I don't. As a programmer, I respect him extensively, but it didn't have no object system back then, and I wanted the better programming language to dog food myself. So to replace plural, and then it must be clean and object-oriented and very good for text processing. Just because I did text processing a lot back then. So, but it's kind of like an excuse. Like I wanted to create my programming language, so I just don't care about replacing plural. But I just need excuse to persuade myself. So just wanted to make my own programming language. Then I created Ruby. Then the World Wide Web has come. So the CGI, the Common Gateway Interface, is pretty much text processing. So the language like Perl, language like Ruby is pretty good for without web programming. So the skyrocketing popularity of the scripting language like Ruby, Python, Perl, and PHP. These languages are getting very popular, and Ruby could write on that way. And if CGI was too slow, it spawns the new process every time. Then the server-side programming has come. The web application is getting popular, and the web application framework has come, like Ruby on Rails. Ruby on Rails is not the first web application framework out there, but it's not the first web application framework for Ruby. It's very productive. So it getting very popular back in 2005, 6 or something. With a great success in web, so many websites are working on Ruby. So like Twitter is working on Ruby. It's originally written in Ruby, but most of them are ported to JVM. That's sad, but we can't help it. And GitHub is running on Ruby, and Best Buy is using Ruby inside. A Disney company is using Ruby inside. So I can safely say we have almost gone anywhere. Yeah, there's so many companies, so many startups, so many websites are using Ruby. So if I say that choose the language for the web, so the most of them will pick one of them. Java, PHP, and Ruby. So the Java is pretty good programming language. And the number of available engineers are very extensive, very big, and it has static typing, so many errors can be detected in compile time static. And in the compile time check, the detecting error earlier is a good thing to have. So, but its static nature, the Java has a static programming language, and its static nature is kind of against the dynamic nature of web. And the PHP, so I met so a few years ago, I met Rasmus Lerov, who invented PHP, and I had a lunch with him. And he said, PHP is not a language, it's a tool. It's a tool like a toothbrush. You don't care about a toothbrush. As a language lover, I have a different opinion. but he said, PHP is a tool. It's a pretty good tool. Yeah, I admit that. But it's a tool to solve a simple task, and the number of available chip engineers are very high. But I won't say no more. But then Ruby. Ruby is the perfect web system. It's pretty good. And it's concise, it's pretty productive, it's dynamic, it's flexible, and fast enough. How is your Twitter? The very big system, very big websites like 100 million access per month is running on Ruby. So most of the cases, it doesn't have any performance problem. But some company has very scale in very large way, like Twitter. So in that sense, so the Ruby might consume too much machines on the data center, or consume too much memory. So I admit that. But for most of the case, Ruby is good enough. So we can safely say that we have almost locked the web. So we have set 1 million programmers, and I wanted to make them happy from programming hell from the other programming languages. From boring tasks, from inefficient development, from lack of motivation. But web is not web is everything. So the web is becoming bigger and bigger. We have the internet, we have the intranet. And so web technology is almost dominant in computer systems and programming, IT industry. But it's not everything. We have the broader wide programming beyond web. I just said that I wanted to save programmers. I believe Ruby has potential to save a bunch of programmers, even wider range, to set the programmer, to change the world. So we want to go beyond the web. So I wanted to introduce you guys some Ruby applications in the future, the beyond web. So for web, we have Rails, we have Sinatra, we have a lot of web stuff in Ruby gems, and so I don't have to introduce you about you are much you know much than me. I'm not a web guy, so you know much about for web. But I want to introduce you about something beyond web. So first of all, I wanted to introduce you about the Fluentd, which is from the Japanese programmer. So maybe it would be the next Ruby or next leading technology from Japan. So Fluentd is a structured distributed logging system. So it's high performance. Even though it's written in Ruby, so it's brilliantly fast. So in some bigger company like DNA and Greek, like in Japan, so they have the huge set of machines. So they have the millions of machines. So each machine generates log, access log, and the status log. So the Fluentd, they collect data from these logs. So it's said that we are living in a big data age, but we need some big data. The big data comes from nothing. The don't comes from nothing. So we have to collect the data. So we need to generate the big data. So Fluentd might be a key for generating big data. So it's processed more than 70,000 messages per second at peak. It's quite a number. 70,000 messages. It's reliable, so it doesn't have any single point failure. So if the single node has down, so you can have the backup node to collect the login access. So it's configurable, and it has the JSON-like structured data. So most of you guys are using some kind of syslog or some related technology, but it's based on text. So you have to parse the text data to collect the structured data. But in Fluentd, so it has structures from the beginning. So it's quite brilliantly fast and therefore very great for the distributed logging. So no need to parse plain text log, and it's open source, and it's sponsored by the company named the Treasure Data, which is in the Bay Area. So you can check it at fluentd.org. The second one, scientific computing. And I know the scientific computing in scientific computing field, the Ruby is not that popular. And the R is a statistic language, and the Python is pretty popular in that time. In university, the Ruby is relatively weak. I admit that. But the science computing is really important. Like it's in twofold: the high performance computing and data processing. So in high performance computing, we use the Fortran, C, C++, and recently Java sometimes. And data processing language, we use Python, R, and MATLAB, and other programming languages like mathematics, Mathematica. So for scientific computing, the problem in scientific computing is the done by non-professional programmers. So they want productivity since they are researching in part. But at the same time, they want efficiency for number crunching. So they use sometimes supercomputers just because they want performance. So if they don't need performance, they can use PC. But they have huge numbers, huge data. So they need to use the supercomputer. So even though it's kind of like a trade-off. If you pursue the productivity, the performance is going down. If you pursue the performance, the productivity goes down. So but the researchers, scientific computing requires both. So it's kind of a headache for language designer, language implementer like us. So, but we can provide the better programming language. So the primary target is to replace Python in the world. So, but we lack NumPy and SciPy, etc. So we started working with Ruby scientific computing for the coming year or two. So Ruby Association, which is the organization that promotes Ruby in IT field, especially the non-web field. So the Ruby Association, this year Ruby Association made a grant for SciRuby, for the scientific Ruby application. And Nmatrix is the matrix library, so which is boost the performance of the matrix calculation this year. So provide a better language to researchers. And in the University of Tokyo, they got the public grant, the government grant from the Japanese government, and to encourage Ruby in high performance computing. Then a graduate student in the University of Tokyo made a prototype of the Ruby compiler, so which used the type inference to determine the type. Then compile Ruby program into C program. So you can compile the Ruby program. You can convert the Ruby program into C, then compile it by using the C compiler to use the high performance Ruby program. So it's for the best case, it has the 90% of the C program performance. It's quite big. Usually Ruby program is 100 times, even 1,000 times lower than C program, the equivalent C program. But using the compiler, if you can inference correctly, inference thoroughly, so it's for the best case, you get the 90% of the C program performance. That's quite a number. So they're working on it. So the maybe near future, the scientific computing field will be much more popular in scientific computing. So the last but not least is the embedding system. So as Professor Tanaka gave a presentation, so we are working on the Ruby on embedding systems. So we have a lot of non-PC system, so typically small on PC, so like appliances like this, or robots like this, or this, or this. So traditionally Japanese companies are very strong in these kind of fields. So there has a demand of the software that embedding in systems like a robot. So, but as the power of the computer inside the hardware is getting bigger and bigger. So as the complexity of the software required is getting bigger as well. So they really need the productivity of the software inside of the systems, inside of the hardware system. So they required something better. So they wanted something like Ruby for embedded systems. Like we have mobile phone and we have mobile. So these are literally computers supported by hardware. So CPU has all So they also use the programming language named Lua, which is from Brazil. So I think it's the only popular programming language from Latin America. So it's quite interesting programming language. So it's designed to be embedded in systems. So Lua is from Brazil. It has embedded API, it is decent performance. But also programming language is kind of like it's kind of some kind of ripped off the JavaScript. It doesn't have any object system, but some kind of the meta table. It doesn't have an object system. The object is emulated by the data structure named tables, and the exceptions are emulated by the nested interpreter call. What if we have the Ruby implemented like Lua? So that's the reason we started the project in mRuby. So it's the name after the Matz embeddable minimalistic implementation of Ruby. So we should have named it Ruby. but it's quite difficult to pronounce, so we call it, we name it mRuby. So it has embedding API, it has VM structures, as a process explained to you before. It doesn't have any global code, it also can be separated. So you can write down the bytecode like a class file in Java. And compiled by itself can be shipped. No person needs for a long time. If you don't use eval, built-in libraries can be configurable. You can drop off on certain classes. So IO file radio Excel process can be ripped off. Actually, the mRuby run on the systems with the operating systems, like that kind of small computer. So it's much smaller than the Raspberry Pi. So it doesn't have any file system, it doesn't have any operating system, it doesn't have any processes. So you cannot provide that kind of classes for that on that kind of environment. So, and the very important point in mRuby is it has the incremental garbage collection. So the reasoning language has memory problem in many fields. Like a small system has very small memory, so that the garbage collection could be a problem. Or the response time or the garbage collection pass time could be a problem in these kind of small, relatively weak computers. And then for the big systems, so the garbage for creating many objects, that the pass time would be tremendous. So that the running on the very big machines, and the 999 people will be solved without any problem, but the last one, very unlucky person, has the 2-second garbage collection pass time. So he has to wait for 2 or 3 seconds for the responsible. The other people get a few milliseconds of the response time. That would be a problem. But mRuby has an incremental garbage collection. So it slices the garbage collection pass time. It's then distributed among the execution time, so that any unlucky people will not have that kind of huge pass time. So it will be really fine in many fields. So originally the incremental garbage collector is implemented for software time. So that it could be useful in the server-side programming. So mRuby now works and provided by GitHub, mRuby, and mRuby on the MIT license. So you can use it for any purpose without anything. So comparing C Ruby or MRI and M Ruby, that's kind of confusing. Matz Ruby implementation versus Matz Ruby. And C Ruby is soon to be Ruby 2.0 and it's matured and fully features. But M Ruby is just released. I mean, just published, just disclosed. There's no real-world application yet. Very small core. And the C Ruby is a general-purpose Ruby interpreter. The application should be written in Ruby. But M Ruby is configurable and to specific purpose to be embedded in the application. So the relation to the application is kind of backwards in C Ruby and Ruby. So in Ruby, application would be written in Ruby. So you can, if you need to add some kind of functionality, so you write a C extension, then add a feature to the interpreter. But in MRuby, so application is written in C or C++, then it calls Ruby time to time. So the relation is backward. So C Ruby is supported among the major OSs like Linux or Mac OS and Windows and some other the Unixes. And then it requires the POSIX API. It's kind of huge API. The MRuby is very portable, requires only C99. And it runs even on the very small computer like that. So we created some kind of evaluation board for Ruby that it has some kind of FPGA MIPS compatible CPU and with an OS, and then we have the ESN series USB on that kind of evaluation board. And as a memory side issues, regarding memories, C Ruby has a big program size, like more than 1 meg. The big memory footprint, more than 10 or 20 meg. This way. MRuby has a very small program size, and the list configuration, in the list configuration, it's less than 100 kilo, and a small memory footprint. And the RAM is, there is some small program requires RAM less than 100 kilo. Then Ruby has very simple C API and Mac Swift GC and focus better on better GC server. And then MRuby has the embedded C API, implemented garbage structures, and focus on smaller GC cluster. And as a concurrency, the C Ruby has giant interpreter lock, and it has really weak concurrency. And MRuby has VMs create a multi-VM in a process, so you can assign the different VM structure for each thread. So we can do some kind of share nothing concurrency in Ruby. So for the better concurrency. And so C Ruby has the memory problem. So bigger the memory rows, the slower GCP can. And weak on bigger memory goes through for them past time. But MRuby has it, as I explained before, they have implemented the garbage collector that helps the post time, less post time. And we plan the generation of garbage collector. It can be used to various fields in the future. So we don't have any real world application yet, but it is a bright future, I believe. Like a controlling robots, the router extension. So the company back in Japan had created the intelligent router embeds MRuby, and they created some kind of interface to the Twitter. So they connected some kind of USB-driven power meter. So if the router tweets, you consume that much of the power from the power outlet time to time. So they wrote all those extension and the Twitter access library in MRuby. So they created a tweeting router. And the people in game industry use Lua to extend the games that they configure or that they write the rules for the AI of the character in Lua. But it can be replaced by MRuby in the future. And some other guy create libuv extension to mruby. Libuv is the backend of the Node.js. So that means that you can write the Node.js style mruby. In a lot of other regions, we want to help programmers to enjoy programming, not just for web, but as many programmers as possible. So include you and me. So the mruby and the Fluentd or the scientific computing project like SciRuby or Nmatrix will expand the happier world of Ruby beyond web in the future. I expect the bright future for every existing programmer all over the world if they like Ruby. So if they don't like Ruby, there are a bunch of other programming languages out there, so I don't care. But you have your mind, you have a brain that fits into the Ruby, so I want to, as long as the Ruby fits your brain, I want to help you to be happy programmers. So happy hacking. Thank you.
What do you think the time frame is? Do you have any idea how long you think this is going to take to get in really good shape?
Depends on the field. Like for mruby, it requires at least a year or two, and the other one, like SciRuby and Nmatrix will be. It is available. They are available right now, so it's quite difficult to predict the adaptation. Like it's a human stuff. It's not human stuff. And technology-wise, it requires a year or two for all of them that I can introduce here.
Is that Ruby going to be like or is it going to be like
Right now, mruby is at the 1.9 compatible. It doesn't have any tool features.
Are there any pieces from mruby that you're thinking about moving back to MRI, in particular some of the pre-parsing and tutoring into the VM and bytecode?
Well, actually, as a language, the mruby is a subset of the Ruby programming language, so that there's nothing you can port back to the language. So the implementation-wise, the mruby has decent performance, but it's still slower than Ruby 1.9. So I don't think there's any technology that can be ported back to the Ruby. So actually, the Ruby tool has the full-time maintainer for the VM this year. So its performance will be improved. I expect the big improvement before the tool releasing next year. So you can expect the Ruby tool performance. But I don't think there's any new technology in Ruby besides memory.
Hi Matz, are you going to TV too? Are you planning to go to TV? Ruby on TV?
TV?
Yeah, like smart TV.
Yeah. I'm not the right guy on TV. You can have Obama on TV.
One more?
Here, I have a real question.
Hajime, what do you think of Node, Scala, Google Go?
The Google Go as a language? The Google Go is pretty interesting challenge to the language. I'm not sure it will be get popular or not, but as a language and technology, it's quite interesting. So for several reasons, the one of them is the channel. So Ruby Go is the Google Go has the structure named channel, which is kind of communication channel between threads, or in their terms Go routines. So in these days, the concurrent programming is getting much more bigger and bigger. So the channel and routing is maybe the right way to go. And then the second fault is that the Go is not really an object-oriented programming language, but it has some kind of structures of typing, which is I believe which is the right way for the static type systems. So in those two aspects, I'm pretty interested in the Google Go. And the other reason is I'm not really love the JVM platform. Thank you.
Okay, thank you.